Scientists like to classify things. So we can classify elements and compounds. These are all pure substances, which is a branch of a previous branching organizational scheme that we looked at previously. Pure substances divided into elements and compounds. We can divide the elements into atomic elements or molecular elements. And the division here is based on what are the individual atoms present as. In an atomic element, you have individual atoms. In a molecular element, like this one for oxygen, there are two oxygen atoms that are covalently bonded to each other, and they form a molecule, but it's not a compound because it's only oxygen atoms. But the individual pieces are molecules. For compounds, we can look at molecular compounds or ionic compounds, and these have to do with the kinds of bonds that they have. This is an ionic compound. We've got a metal and a nonmetal. There's a transfer of electrons. They make ions. The ions are attracted to each other by their opposite charges. In a molecular compound like water, we have nonmetals. The nonmetals will form covalent bonds. They'll share electrons because hydrogen and oxygen are both nonmetals. That's not the best example. I'll talk about carbon monoxide. If you have carbon and oxygen, they're both nonmetals. They both would want to form negative ions. So in order for them to form an ionic compound, somebody's going to have to really go out of their way to become positive. Nobody wants to do that. None of the nonmetals are going to do that. So because nobody will be positive, then they have to share. So more details. I'm going to go over this fairly quickly because you guys can read. Atomic elements, they have single atoms as their basic unit. This describes most elements. Then we have molecular elements. These exist as molecules. It could be two atoms covalently bonded together or more. So there are 7 elements that exist as diatomic elements. Di is a prefix meaning two, atomic meaning atom. So these are 2-atom molecules. And then there's phosphorus and sulfur are polyatomic. Phosphorus exists as P4, sulfur as S8. I'm telling you about that. I don't expect you to remember that. We do need to know which elements are diatomic. And so here we're showing them on the periodic table. There's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's 7 of them. A pattern I noticed is that if you start at element number 7, they make the shape of a 7. It's kind of cool. Plus hydrogen, because he's the baby brother and he has to break all the rules. He's just not going to do what everybody else does. So he's over here also being diatomic. This periodic table also shows some polyatomic molecules. That's nice, but we don't need to remember that. So how do we remember these 7 diatomic molecules? There's a couple of different ways. One is with a mnemonic sentence. Horses need oats for clear brown eyes. It's all great until we get to this last part. It's like, wait, eyes, the letter I, eyes. We can deal with that though, right? H for hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. One I remember from high school is Brinkelhoff. And that's an attempt to take those element symbols and make a pronounceable word out of it. So whatever works for you, you need to know those. Any questions? Moving over to the compounds. Molecular compounds, 2 or more covalently bonded non-metals. Okay. Individual components of these compounds are molecules. We've looked at water a lot. This is propane. It has individual molecules. This is different from an ionic compound where you have alternating cations and anions all throughout the thing. These have individual units. And ionic compounds are composed of cations and anions. They are ionic, they have ions in them, right? There has to be at least one cation and one anion because you have to have opposite charges for them to be attracted to each other. The cation is almost always a metal. There's only one exception we need to know about, ammonium, and I'll mention that again later. The anions are going to be one or more nonmetals, and those will be our ionic compounds. So ionic compounds don't have molecules, but we can't really refer to this piece of sodium chloride as, we can't count up how many sodium atoms and chlorine atoms are in this piece, right? Because all the different pieces, here's some table salt, each of those has a different number of chlorine atoms and sodium atoms. They all have the same ratio though. For every sodium ion, there's one chlorine ion. So what we do is we use the empirical formula for ionic compounds. It's going to be the lowest ratio of the ions that give us a neutral compound. And so this is the formula, and so instead of referring to a molecule, we refer to a formula unit. Because a formula unit is the smallest piece of this that would still be sodium chloride, right? There'd be one sodium ion and one chloride ion. That would still be sodium chloride. That's a formula unit. Any questions? I don't know what's going on with my voice. We can have polyatomic ions. Most of these are going to be anions. And it's important to understand, again, in an ionic compound, we're going to have two ions. And I'm going to tell you right now, I'm going to lie to you a little bit in 1A. It's for your own good. It's like, we lie to our children sometimes because they don't need to handle the whole truth. They don't need to be burdened with the whole truth of how the universe works, right? They just need to know what they need to know. I'll often preface that with some qualification because I have a hard time saying things that aren't exactly true. But in this class, all ionic compounds will have two kinds of ions, one cation and one anion. There are other ionic compounds, but we're not going to talk about them this semester. So when we look at this compound, NaNO3, what kind of an element is Na? It's sodium. Is it a metal or a nonmetal? How do we know? We look on the periodic table. Where is it? It's way on the left side. It's a metal, right? We have these other elements, nitrogen and oxygen. Are those metals? No, those are nonmetals. We have metal and nonmetal. That tells me this is an ionic compound. Because this is Chem 1A and not, inorganic chemistry or something more advanced, this has to contain just two ions. Sometimes students want to make it into three. Well, there's three elements, right? Why can't we have sodium, nitrogen, and oxygen ions? Because it doesn't do that. Two ions. So the metal is the cation, and all of the nonmetals together are the other ion. And we're going to learn more about them later. But we should recognize this as what ion? Nitrate. Some of these were on actually all three of those were on the list of things to memorize, right? So nitrate, carbonate, hypochlorite. So these are ionic compounds. Each of these, the formula starts with a metal. And then the other elements are nonmetals. So that's an ionic compound. It has a polyatomic ion in it. Any questions? Yes?
So metal is the cation?
Metal's always the cation, yep. Metals form cations. Non-metals form negative ions. Non-metals, negative anions. Okay? We are going to learn how to name things and write formulas for the things, but the first step is identifying what kind of a substance is this. If we can't identify it, we can't give it the correct name. It's like, if you're playing a game with a 3-year-old and the 3-year-old doesn't recognize that what you're talking about is an animal and they think it's a rock, right? Then they're going to have a hard time coming up with the right name. So we're asked here to classify as an atomic element, a molecular compound, or an ionic compound. So fluorine. First of all, element or compound? Element. Atomic or molecular? It's molecular. Horses need oats for clear brown eyes. It's one of the 7, right? So this is an element, but it's a molecular element. So I'm going to call it Me, molecular element. Okay, this one, N2O. Is that an element or a compound? It's a compound. So here's, just a trick. All element symbols start with a capital letter, and they only have one capital letter. So in this formula, there are 2 capital letters. There must be 2 elements in there. If you have more than one element, it's got to be a compound. So this is a compound. It's a something C. Molecular or ionic, we have to look at what kind of elements are those. They're both nonmetals, right? We identify that from their position on the periodic table. So in order for it to be ionic, there has to be a metal and nonmetals. Here we have 2 nonmetals. So what kind of a compound? Molecular compound. Silver. Element or compound? Element. So hopefully you recognize that as an element name. Another clue is most compound names have 2 words. Not all of them, but the vast majority of them have two parts to their name. So if you see a single name like fluorine or silver, there's a good chance that it's an element. Is this one atomic or molecular? It's atomic. It's not one of the 7. So this is an atomic element. How about this one? K2O. Ionic compound. Ick. Potassium is a metal. Things like potassium and sodium, you might not think of as metals because we never see things made out of potassium metal because it reacts violently with water. And so, you can't even have just a jar of it unless you have it covered in oil, right? Things like iron or copper we recognize because we deal with things. Your pennies have copper in them. You know that that's a metal. Potassium, you think, well, that's what's in bananas, right? It's good for you. I ate that this morning. I ate a banana on the way to work. I ate a metal? Well, sure I did. Lots of things have metals in them. But it's not like you're chomping down on, aluminum chunks or something. So, metal, non-metal. So especially early days when you're trying to identify, try to think of it, I think this is ionic, but then look at the periodic table and double check. Is that a metal and a non-metal? Find it on the periodic table. Okay, how about this one, Fe2O3? Ionic compound. Again, there's a metal and a non-metal. Any questions?